We can use indirect proofs quite a bit when we're dealing with number theory. We're not going to deal with this as much. I just kind of want to show you a little bit of an example where we use proof by contradiction quite a bit. So whether you really watch this entire video or not, it's just an idea as another way that we could use this type of proof. So write an indirect proof to show that if x plus 2 is an even integer, then x is an even integer. So first thing, we need to write down what is actually given to us and what are we trying to prove. So given is always after the word if, so we're saying that x plus 2 is even. My conclusion is always after the word then, so x is even is what I'm trying to prove. A couple things that you need to realize is that when I'm dealing with even numbers, I'm going to suggest that I can write every number and every even number as 2 times some value, call it k. This will always produce an even number. You can plug in any value for k that you want. You can try 1. 2 times 1 is 2. 2 is even. Try k is 7. 2 times 7 is 14. 14 is even. You can try another even number, say 6. 2 times 6, that's 12. 12 is even. So you can see that 2 times any number is always going to be even. So if I want to make it an odd number then, remember all of our numbers go even, odd. So I'm going to take an even number and add 1 to it. That will always produce an odd number. Okay? So now we can actually get into the idea of our proof by contradiction if I know these two scenarios. So we're going to start with step 1 again. Remember, step 1 is just stating the opposite of whatever I'm trying to prove. So instead of saying x is even, we're going to say x is odd. Okay, so step 2 then, this is where we're going to use our logical reasoning, and we're trying to come with a contradiction to our actual given up here at the top. We're trying to come up with, basically, instead of saying x plus 2 is even, we're going to come across a scenario where x plus 2 is odd. Okay, so using my assumption down here of step 1, x is odd, we would say then that x is equal to an odd number, which we just said is 2k plus 1. And since I know that my given is true, I'm going to plug this 2k plus 1 into my given up here at the top. So replace x with 2k plus 1. Now I have 2k plus 1 plus 2 for my scenario, and we're hoping that this is even. And I'll even write that. Okay, keep moving. Now it's very tempting to actually add this 1 and 2 together. I'm not going to do it. I'm actually going to flip the order. So we're going to say now that 2k plus 2 plus 1 is even. At least we're hoping is still even. Keep going. I do want you to see this part. This is why I flipped the order. The 2k plus 2, don't worry about the 1 for now. But if I look at 2k plus 2, those both have a 2 involved. So I'm going to take out a 2. I'm left with k plus 1 plus 1 is even. At least we hope it's still even. But when looking at this, we just said 2 times anything is even. So looking at this part, 2 times k plus 1, if I plug anything in for k, that's going to be even. But then I add 1, which makes it odd. That is my contradiction right there. So we're going to go down to step 3 and state that 2 times k plus 1 is odd for every k value, which is contradicting our given. I can't have both an even number and an odd number at the same time. So that would be considered my contradiction in this case.